உங்க பிசினஸ் grow ஆகணும்னா நிறைய சேல்ஸ் நடக்கணும். நிறைய சேல்ஸ் நடக்கணும்னா நமக்கு நிறைய லீட்ஸ் வேணும். நிறைய லீட்ஸ் எப்படி ஜெனரேட் பண்றது? அதுக்கு இந்த 3 விஷயங்களை நீங்க பண்ணணும். பெர்ஃபார்மன்ஸ் மார்க்கெட்டிங், கான்டென்ட் மார்க்கெட்டிங் அண்ட் பிராண்டிங். இதுல ஏதாவது ஒரு விஷயத்தை நீங்க சரியா பண்ணலன்னா சரியா லீட் ஜெனரேட் பண்ண முடியாது. அப்படியே பண்ணாலும் அதுக்கு நிறைய செலவு பண்ற மாதிரி ஆயிடும். அப்புறம் ப்ராஃபிட் மார்ஜினே இருக்காது. இந்த 3 விஷயத்தை எப்படி சரியா பண்ணணும்னு கத்துக்க ஆசைப்பட்டீங்கன்னா வர சண்டே நாங்க
Hi, good evening all. Am I audible?
Yes, sir.
Yeah. Okay. Hira, you have some question. Could you please clarify about the exam format? So, generally exam format is like you are doing some assignments, right, in NPTEL? Are you doing it or not?
Yes, sir. I've written only one paper. This is my second year. In my first year, I did one course in Python for data science, a 4-week course. So that was 50 questions and it had all MCQs. But I received an email for this exam and it says we have MCQs and essay type. So
Okay, that's okay, fine. In NPTEL, currently you are submitting the weekly assignments or not?
yes, sir.
So every week there will be some assignments there.
Yes, sir. I'm submitting
for this course. Okay. So the questions pattern will be same only. Like they will give mix up of
so like MCQs,
and then this is like more Python programming. They will give some code snippets.
Okay, sir.
And then they will ask you to like what is the output, or they will miss some statement. You need to fill up that statement, Python code. Okay. So sometimes they will give a small Python program also. You need to execute. Okay. But it's mix up. The questions are combination of MCQs and then fill in the blanks.
Okay.
And then there is a chance 1 or 2 programs they will do try to.
So essay group is like we have to write the program for the
that will be very less weighted only as per my knowledge. Okay. So if you still have any questions, you may check that question answers. There will be one forum is there.
Okay.
Like actually NPTEL team will be there. Actually we are not the actual NPTEL team. They will give more exam related things. So as per my knowledge, there will be more weightage for MCQs, then fill in the blanks, and then some weightage for programs.
So equal weightage they have?
No, we cannot say equal weightage. More weightage for MCQs only.
Okay, sir.
It is 30-40% is MCQs, then
The total number of questions here also will it be same 50?
No, this may, I don't know exactly, but it will vary.
Vary. Okay, sir. And it's fully system based, no, sir? Not pen and
System based only, na? All NPTEL exams are system
you
based
know,
only.
certain courses it was for a pen and paper also, I guess.
Pen and paper, no, no, I don't think. It's CPT only, I mean computer based tests only.
Okay, sir.
Yeah. Any other questions you have?
No, sir.
Okay. So, okay, I think uh, so. Anybody is having specific questions? If you have any questions, you ask me. Otherwise, I think the week 7 content is related to trees. First, I will explain some basic fundamentals of trees. Then I will move on to coding part. Okay, how to implement these trees by using Python. So, if you don't have any questions, any questions? Okay. So I will give some basic fundamentals about trees. Maybe some of you already know these things. You might have studied in your data structure course. Okay. Anyhow, let me go through one by one. Okay. So today live session is related to trees. Okay. So these are the outline topics. Okay. So what are the different types of data structures are present, and then we will see some examples for each data structure. Then we will mostly concentrate on tree data structures in this live session. And then the basic terminology we are going to use in trees. Then we will see the tree abstract data type, how a particular tree will look like. Okay. Then we will see some traveling algorithms like how to travel the edges on trees. Okay. So there are different algorithms are there, like in order, pre-order and post-order kind of things. So then we will discuss binary trees. Okay. So the fundamental tree is binary tree. So in this we will see a binary tree, then how to implement this binary tree by using Python. Okay, the coding part we will see later, but I will give some details about these trees. Okay, so coming to data structures. Okay, there are different types of data structures are there. So broadly we are going to categorize these data structures into two types. One is linear data structures, another one is non-linear. So I think you already know these things. Okay, linear data structure, like the examples will be can you say what are the examples for linear data structure?
Stack queue,
What are the linear data structures, you know?
stack queue.
Okay, stack, queue, arrays, linked list. So all these data structures comes under linear data structures. Then what is non-linear? Linear means like it's a
Circular.
sequential fashion. You are going to handle your data in a sequential manner. So what do you mean by non-linear? So what are
graph tree.
yeah, graph trees. Okay, so most of the real time, okay, um, environment, you can see this trees and graph data structures only they will use it. Okay, so non-linear means it should not be like sequential fashion. Okay, so coming here, okay, linear data structure. Okay, so there will be a number of elements, I already said. Okay, so it will, you are going to organize, you are going to store this data in a sequential manner. Okay, so that's why we are calling the term linear means like a sequential manner. Okay, so whatever the data you are having, you are going to organize it in a sequential manner. Okay, so because whenever you want to represent or you want to store this data in memory, okay, so this will be very easy, a linear data structure. Okay. So the best example for this is like arrays and linked lists, as I mentioned. Okay, so like arrays means you are going to take some index value. Okay, so you can directly access the particular memory locations with the help of index. Okay, then another data structure, linked list is there. So if you want to access any element in the linked list, okay, so there will be some nodes and pointers are there. So you need to point out, or you need to um, point that particular node with the help of these pointers. Okay, so these two are um, comes under linear data structures. Anyhow, our interest in this session is trees only. When you are going to use this thing, okay, like arrays are useful when the number of elements to be stored will be fixed. For example, you have a memory of 10 MB or 1 GB, okay. So if you know the memory size, then you can able to store or you can able to use this array data structures. For example, you don't know how much size you want, then this case, suppose you have a memory of 1 GB or 10 MB, so you want to store some movie or some song in your mobile or somewhere, okay. So in that case, what will happen, we cannot fix, okay, which data structure, okay, or you cannot able to fix arrays now itself, okay. So my point is, arrays will be very useful when the number of elements to be stored is fixed, okay. You already know how much size your array, and then how many number of elements is there. In this case, arrays will be the best one, okay. Similarly, operations like if you want to traverse or if you want to sort the elements, okay, so then arrays may be good one, okay. On the other hand, you have linked list. When you are going to use your linked list means, for example, then the number of data items in the collection are likely to change, okay. So if you want to modify or if you want to change your items like dynamically, okay, like this array is static kind of thing, like linked list is dynamical if you want to change without disturbing the other elements, okay. So you can able to change, okay. So that is the case where you are going to use arrays and linked list, okay. Now come to non-linear data structures, okay. Generally in linear data structures, the data elements is organized in a sequential fashion. When it comes to non-linear, it won't be like you cannot organize this data in sequential fashion, okay. So a data item in non-linear data structures could be attached with some other data elements, okay. There will be always some linkage will be there among that data elements, okay. So if you do some modification or if you want to change something, it will reflect the other data elements in the non-linear data structure, okay. So this is, I mean, this kind of representation, it is not there in arrays and linked list. So for example, in arrays, if you want to remove an element, so you can remove it, okay, with the help of index you can remove it, even similarly for linked list also. But in trees, if you are removing a particular data item, so there are other elements, there is some kind of relationship exists among those data items. So you need to arrange or you need to organize the other data elements properly, then only you need to delete it or you need to take some action on those elements, okay. So the best example you already mentioned, okay, trees, graphs, even multi-dimensional arrays also comes under like non-linear data structures only, okay. So multi-dimensional, okay, generally array means two-dimensional thing. If you are going for multi-dimensional data, so it will comes under okay. So like this is examples, a multi-dimensional array is a simply collection of one-dimensional arrays. So it will be collection of many one-dimensional arrays. One dimension means many one-dimensional arrays. That's why the name is saying multi-dimensional. So like tree is a data structure that will be made up of different nodes. So there will be some linkage is there on nodes. We are going to call these nodes as linked nodes, which can be used to represent some hierarchical relationship among the data elements, okay. Similarly, graph also. Can you please tell me what is the difference between graph and tree? So trees will have nodes and then edges, and then hierarchical structure will be there, hierarchical relationship is there among elements. And then graph is also kind of same thing, okay. Graph will have some kind of vertices and edges, you may call nodes, okay. So what is the difference between tree and array. Sorry, tree and graph. What is the difference between tree and graph? Anybody? Do you know data structures concept? What is the difference between the data structures, tree and graph? So
So tree has a root and no cycles. Graph will have cycles.
yeah, okay. Yeah, even though graph will have root and edges, vertices, okay. Only difference is in tree you cannot find cycles. There will be no cycles in tree data structure. In graph there is a possibility you may get cycles also. Okay. So that is the major difference between tree and graph. So is there any kind of, and then we can say, okay, so tree is, I mean, you can call some trees or graphs, but you cannot say vice versa. Graphs are not like trees, okay. So graph is like subset of okay, tree is subset of graph also, but graph is not a tree, okay, because there will be some cycle may be present in graph, okay. Mm, so and then we will see the difference between linear and non-linear data structures. What is the major difference between linear and non-linear data structure is, so this how you are going to organize your data with respect to these data structures, okay. So that is the key difference. So in later linear data structures, data elements are organized in a sequentially. uh, that's why whenever you want to implement these linear data structures, it is very easy to implement in computer's memory, because it will go in sequential manner. You want to store elements one by one, okay, and then that memory also you already know how many elements are there. You can try to fix this memory size also in initial stage itself, okay. But in non-linear data structures, the elements are attached to several other data elements, okay. So and then there will be some relationship exist among those data elements. So whenever you are handling these non-linear data structures, you need to take care of other data elements also. Whereas in linear, you no need to bother about other data elements, okay. You just follow in sequential fashion, okay. So now come to what is the difficulty to implement these things, okay. So the due to this non-linear nature, okay, so they might be difficult to implement in computers memory compared to linear data structures, okay. So when you compare the memory aspects, so non-linear data structure is difficult than the linear data structures. So because we already mentioned, right, the next one is selecting one data structures type, okay. So whenever you want to select which data structure you want to use for your application or your requirement, so based on that you need to select, okay. It depends on your application and requirement aspects, which one is you need to select, okay. So for example, I will give one example, okay. There is a company called XYZ. So in that XYZ the company, there will be many employees are there, many employees data is there, okay. There will be several data records are there. You need to organize the data records, okay. So the first thing is you are going to ask is, so whenever the employee data is there, there will be a lot of records. So like employee means employee ID is there, employee name is there, employee address is there, and then the other details like geographical details, we are going to maintain all those employee details, okay. So the first thing is you want to ask to create a database for all these employees, okay. uh, After that what you will do is, so to start your work, okay, so you need to list everyone in the company along with their position means like designation, okay, if you take and other details, okay. So generally the most in employee aspects, the primary details what you need from the employee means like employee ID, employee name, and then employee designation. Okay, these three are the mandatory things. Based on these three only, like they are going to fix your salary or they are going to organize your data, like your roles and responsibilities. Everything comes under this particular sort of data, like ID, employee designation, and then employee name. Okay, so like this is the table. Like we have employee name. As of now we don't have employee ID. You just assume that like employee 1 2 3 4 5 6 like this. Okay, so this is the position. Okay, manager, like vice president, employee, vice president, president. Okay, like this. Okay, so generally this employee name is sorted in the ascending order of based on their name. Okay, so these records are arranged based on employee names. They are arranged in some order, ascending order. Okay, from small to A to Z. Okay, and then their designations will be there. So what is the drawback based on this kind of employee table? Okay, like whether what kind of data structure it is. This employee table, this table is employee table. Can you say what is this table? I mean, what kind of data structure it is?
Stack.
Okay, anybody else? You can classify in some broad classification. I said there are two different types of data structures. One is linear and non-linear. This employee table comes under which data structure? No, no. This is not. Tell me, is it linear or non-linear? So it's not non-linear data structure. Why? What is the reason? This data structure is linear data structure.
It is linear because they are organized in proper rows and tables.
Yeah, yeah, I already said. Okay, they arrange this employees data in a sequential fashion based on the employee name. This okay, this is called record. Okay, in database aspects, these are the fields or attributes. Name and position will be the field, means like the kind of information, or the column. Okay, this is column, right? Column and rows. Generally, this is column and rows. Everything we are going to organize. Row is nothing but in database aspects it is record. Okay, this is one record, one employee record, another employee record, another employee record, like this. Okay, so these are the fields or attributes. This is column. Okay, column, field or attribute. So this attribute is nothing but it will describe these records. Okay, for example, if I say position, position will describe you. Okay, so for example, now also your position is student or faculty, something is like this. Okay, this position field or position attribute will reflect you. Similarly, Aaron, for example, I say Charles. Charles is the vice president of that particular organization. Okay, so this data is organized in a sequential manner. That's why we are calling this as linear data structure. Now, why do you need a non-linear data structure to organize this kind of thing? Can you say something? Why? Uh, Suppose this employee is there. This employee want to report his higher authority. Like you may call it as this employee higher authority is manager. Manager higher authority is vice president. Okay, so vice president is going to report to. This is like some kind of hierarchy, or based on their designations or position. We need to organize this data into in hierarchical fashion. Okay, so generally employee, he cannot go on directly report to vice president or secretary, right? First they need to inform to manager, manager to vice president, to president or secretary, whatever it is. Okay, so whenever this kind of things will comes into picture, okay, so there is a need for the hierarchical data structure. That data structure is called a non-linear data structure. Okay, so like I will explain some limitations or disadvantages of using these tables or linear data structure. See here, okay, this only shows the one view of the company. You also want to use your database to represent the relationship between your management and employee. Management means like president or secretary or whatever. Okay, so they will be the managerial people um, in some company. Although your list contains both name and position, it does not tell you which managers are responsible. Again, okay, manager means their designation is manager only. If you go for some companies, they have different managers like IT manager or hardware manager or product manager or project manager or team manager. See, in manager designation itself, there will be some sub designations are there. Okay, am I right? This employee, okay, testing manager, okay. So when there is a particular employee is there, they need to report for the concerned manager. So if you want to handle these kind of things, uh, you cannot handle this kind of hierarchical relationship um data by using linear data structures like arrays, like what you said, linked list. Okay, so so that is the disadvantage if you are using tables. Okay, so you can decide, okay, if you are taking non-linear data structure like tree and graph, something like this. Okay, so if you are going for non-linear fashion, so you can able to represent these relationships among your organization. You can represent in effective fashion. Okay, so these are the advantages. So with the help of these advantages, you are going to come up with some novel concept that is like non-linear kind of thing. Okay, this is non-linear. So see here, this is the hierarchy. Like John is the president. Um, wait a minute. So this is the for to represent your data in better way. I mean better fashion or effective fashion. So we are trying to represent the same data, whatever you have seen here, in tabular format. We are representing like this. Okay, the same name is the employee name and then designation. Okay, so this is the designation. All these people are employees, like Jock, Marathon. Okay, these two people, there will be some manager is there, Larry. They may comes under one particular team. This is another team. So these two people, they will represent some vice presidents also. Okay, so again there is a chance we may have regional heads or vice presidents. Okay, regional vice president. For example, if we take India, for south or north or northeast, whatever. Okay, there will be some vice president for a particular region or 3-4 states. Okay, so they will monitor tasks for this set of people. Okay, so like this here also. Okay, so this structure is called tree structure. Okay, so this is called tree structure or non-linear data structure. Okay, so these two diagrams are examples for whatever we have seen initially. One tabular structure, the next one is one hierarchical structure. Like, so these are the different data structures examples. Okay, so your data is organized in the list. This is um, like I said. Okay, in one of the data structure, your data is organized in the form of a list. That is list of employees. This is very useful for keeping the names. They followed all the employees names in alphabetical order, so that we can locate the employee record very quickly. For example, if they are arranged the data in tabular format, if I say Larry means, directly I can go. Okay, because this is arranged in alphabetical order, you already know I can find out the letter, I mean the name starts with L, I can able to figure it out, I can able to identify easily. So that is the point. We can remember, we can able to access the employee record very quickly. Okay, so however the structure is not very useful for showing the relationship between the employees. A tree structure is much better suited for this purpose. Okay, so this is tree. Okay, now I will explain tree data structure. Like tree is non-linear data structures that models hierarchical representation or hierarchical organization. Okay, so the characteristic features are that each element may have several successor. Like tree, I will show you some terminology a little later. As of now, you just remember successor or children. Okay, so and every element except one element, the element is one element is called root, has unique predecessor. Okay, I will tell you what is the successor and predecessor. Okay, so unique predecessor means this is called parent. Okay, so there are common, like this tree you are going to use in, like you want to organize your files. Okay, even in your computer. Okay, so the kind of structure like in your C drive or my computer, or even in Unix or Linux also, they are going to organize all those files in tree structure only. Okay, all the computer file systems are trees. uh, they will use either C++ or Java concepts. Okay, anyhow. Okay, so like what is tree? Okay, tree is nothing but a abstract model of hierarchical structure. Generally tree contain nodes. Okay, and then edges. Okay, or else sometimes you may call tree consists vertices, it is combination of vertices and edges. These edges are connected to vertices. Okay, so like a tree consists of nodes with a parent and child relationship. Okay, so what are the different applications of trees means, like organization charts, file systems, then programming environment. Okay, so these are the some applications. Okay, there are many other many applications also. We will come to formal definition of a tree. Okay, so here is the recursive definition for. Okay, a tree is a pair of R comma S, where R is a node, S is the set of disjoint trees. Okay, so none of which contains small r. Okay, so S is the set of disjoint trees in the sense, so you cannot have the same node in these disjoint trees. Okay, so that is the meaning of tree. The node R is called the root node of the tree, and the elements of the set S is called subtrees. Okay, so the set S of course may be empty. So this set, okay, it may empty or it may contain one element or two elements. Okay, so the elements of the trees are called nodes. Okay, from now onwards, whenever I say node, you assume that that is the data element. Okay, or the data. Okay, so this is root, parent and children. I will explain with one example. Okay, first I will show you the tree structure. This is one example for a tree. So this is the root node, these are the child nodes or parent, I mean leaf nodes, these are the parent nodes. Okay, see here n1 is the parent, so you may call sometimes this root node also parent node of.
So it is in the better representation that image has been shared. So
Which image?
better representation that image has been shared. So
This one.
yeah,
Can I explain this? This is generally okay. So this is like tree structure, right? This tree will have, okay, this node is called root node or parent node. Then these are the childs for this node. Okay, so when you say this is parent, then these are the child nodes. If you say these are the child nodes, this chain node's parent is this one, okay, these two chain nodes parent is this one, then you can call this is like this is parent means this is grandparent, like, so the kind of relation is like this, okay. So anyhow, this is the root node or parent node, this is the child node, okay. So when you say this is grandparent, then this is parent node, then these are the child nodes, then whatever the nodes which you don't have any other data elements, okay, so these nodes are called leaf nodes, okay. Leaf nodes means the end nodes, okay. So now come to here, see here, this is the example for a tree. In this case, n1 is the parent of n2, n3 and n4 only. This is the parent, okay. Then come to here, n2 is the parent of n5 and n6. It is the parent, okay. Then n3, you don't have any child node. Then you are going to call this n3 is like, you can say leaf node. Am I right? Similarly, n4 is the parent for n7, okay. So n3 and n4 are the children of n1. So while n5 and n6 are the children of, okay, the same thing. This is the terminology in tree. You can use this terminology, okay. From now onwards, we are going to use parent node and child node, or simply sometimes parent and child only, okay. Now come to here, like this is already over. Like x is the root of tree, I mean, see, S is the set of subtrees, okay. So when you say this is one tree, okay, if you observe this thing, this is called subtree. This entire tree is called tree. If you take a part of this particular tree, this is called one subtree, another subtree, then another subtree, okay. So we can say there are three subtrees are there in this tree, okay. So you can divide. So what is subtree is nothing but, okay, suppose if you remove any edges, this is the edge, okay, like this is vertex or node, this will be the edges. Edges are generally used to represent the relationship between two nodes. So if you remove any edge, if it will show some kind of data elements here in the form of tree structure, okay. So I already mentioned tree means at least one node it will present. So here three nodes are there, again it is some form of tree, okay. So like these are the subtrees, okay. Now the terminology is, a node with no children is called leaf node. I already said if there is no node, then you are going to call, in this example, n5, n6, n3, n7 are the leaf nodes, okay. A node with at least one child is called internal node. See, this is, if you are using the terminology root node, this is the root node, this is the leaf node, you are going to call this as internal node. Yeah, tell me.
This
Hello.
no sir. So far, which one you was explaining wasn't being presented, sir.
Presented?
So far, which one he was explaining that N4, N3 wasn't being presented, sir.
Presented in the sense?
It was not presented, sir. Now it is visible.
Now it is visible, okay. So what I am giving is, I am trying to give some terminology. Before I want to give some Python code, right? So if I write directly Python code for tree data structure, you will get some confusion. I am explaining some basic fundamentals which involved in tree data structure. I am explaining like when you say this kind of structure, this is nonlinear data structure, like this is tree structure. Like if you see a tree, okay, like you just take normal tree also, you remove the tree and you just change the direction from bottom direction to top direction, okay, like bottom to top, it will look like this only, okay. you understand, if you remove any tree or any plant, you just change the structure. Okay, so these are some leaves kind of thing. Okay, that's called leaf nodes. Okay, if you are using the terminology root node, then these nodes are internal nodes. N2 is the internal node and N4 is the internal node. So this is the terminology involved in the tree, right? Like any questions? Did you understand the terminology involved in the tree data structure? So let me check. So if you have any questions, you ask me. I will repeat one more time. Otherwise, okay. The next thing is connected tree. Okay, connected means a tree is connected in the sense that we start at one node and other than the root, okay, you move from parent to another parent. Okay, like as I mentioned the previous case. Okay, so for instance, starting at n7, okay, this is the n7. See this example, we move it to its parent is n4, n7 parent is n4, and from there n4 is the parent, and n4 is having the root is n1. Okay, like this is connectedness from n7 to n4, n4 to n4, n1. Okay, so if you say this is like connection. Okay, these edges are called connections among your tree nodes. Okay, this is called, if you are having this kind of structure, this is connected tree. If you remove some edge, for example you remove this one, then these two are not connected. There will be, if you remove this edge, this is one tree and this will be the another tree. Okay, there are two trees are there, you may call this as disjoint trees. Now this is joint tree or simply tree. If you remove some edge, you can able to get two different trees, then the trees are called disjoint trees. Okay, like that is the importance of connectedness means, so all the nodes present in the tree are connected to each other. Okay, like ancestors and descendants. Okay, like you already know. Okay, ancestors means like we are also having. Okay, like child is there, child parents are called parent node, then child parents are called grandparent. Okay, similarly we have some ancestors are there. Okay, like descendants means like our childs are there, from our child to there are some grandchildren. Okay, grandchildren to grandchildren, those are the descendants. Okay, so like if you show the relationship between parent and child relationship, can be extended naturally. Like, so in this case only three levels are there: level 1, level 2, level 3. For example, if you say these are the child, parent and grandparent, what in case if you have one more node here, then this is grandparent, you are going to call it as ancestor, like one more node on top of this one. Okay, grandparent, like to represent this extended nature, we are going to call it as ancestors. Like descendants means we have some more nodes here. Okay, here. Okay, so if you are going down, children, grandchildren, 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 we are going to call this terminology as descendants nodes, right? So that is the description about ancestors, I mean, and descendants. Now come to path and path length. Okay, more formally, I will explain this with one simple example. Like this is the same example. N1, N2, N6 is the path of N1, N2 and N6. Okay, these three nodes they are telling. Okay, so whenever if they are asking what is this length of these things, okay, N1 to N2 and N6 means the length is 2. Okay, from here to here 1, from here to here 1. Okay, so there will be the path length is 2. Sometimes this is called levels also. This is 0th level, first level, second level. Okay, so there will be the path length means this is one path, another path. Okay, so like, so more formally, a sequence of nodes will be there in the tree. So we can use path length to represent this. Okay, then height and depth of a tree. So if you want to say what is the height and depth of tree, if I ask what is the height of a node n, is the longest path from n to leaf node. Okay, the height of the tree is the height of the root node. Okay, similarly depth or level of a node is the length of the path from the root to n. Okay, so in this example, okay, for example, if you want to say height means n is the root node. Okay, in this previous example. Okay, the longest path from n to a leaf node. Okay, I will say this is my n, this is my leaf node. So whatever the path length, you are going to call it as height. Okay, this is height. Depth means, so root to n. Okay, you assume that there will be another node. Okay, so you may have like this, so that will be the depth or levels. I already mentioned. Okay, height or level. Okay, you got my point. What is the difference between height and level of the tree? Can you explain? Someone will explain. Difference between height and level of a tree. So basically what I am telling is, I am telling to height means the longest path from the root node, this is my root node, to leaf node. You are going to call it as height. So level means how many levels are there. Okay, this is one level. Generally levels will start with 0. This is level 0, level 1, level 2. So in this case, in this tree there are 3 levels are there. Height means the path length is true, path length is true. So you are going to call the longest path is from n1 to n2 or n6 or n5 also. So only 2 edges are there, so the path length is 2. But level is, there are 3 levels: 0 level, first level, second level. Is it clear? Any questions about the terminology which I am using? Any questions? So I hope you understand this. Is it clear? Okay. Okay, see here, this is an example. Node 1 has height 2, n1 has height 2. Okay, now I am explaining height and depth. Okay, node 1 has height 2, n2 has height 1, only one node is there, leaf node, and then n3 has height of 0. So this don't have any leaf nodes. The height of n3 is 0. Okay, in fact whatever, not only n3, any leaf node will have height will be 0 only. Okay, the height of the tree is, the entire height of the tree is 2. When it comes to depth of n1 is 0, depth of n2 is 1, depth or sometimes it may be level. Okay, depth of n1 is 0, it will starts with 0, n2 is 1, n5, n6 or n7, whatever is this depth 2. Okay, so that is the example for height and depth. Any questions? Okay, now we will see some more terminology. The size of the tree. When you are going to say what is the size of the tree, is the number of nodes it contains. If you want to say the size of the tree, uh, you need to count the number of nodes, then you can say that size of the tree. Then if you want to say degree of the, this is the other terminology. Degree of the node means the total number of subtrees attached to that node is called degree. Okay, so the degree of the tree is nothing but the maximum degree in the tree. Then nodes with common parent are called siblings, like brothers. Okay, so we will see one example. Okay, so the degree of this thing, degree of 20 is the degree of this node is 3 because it has 3 subtrees. What is the degree definition? The total number of subtrees attached to the node is called degree of the node. For this, what is the degree of this node means? There are 3 subtrees are attached. The degree of the node 20 is 3. Can you say what is the degree of 60?
So actually, we could see only the PowerPoint presentation. We are not able to view the trees.
You are not able to.
Now it's
Now it's visible.
yes, sir.
Now,
Yes, sir. Yes, sir.
oh, maybe some connection issue. Okay, the degree of this tree is called like what is the degree of 20 means there are 3 nodes are attached to this one. These 3 nodes are 3 subtrees. We can say the degree of this particular node 20 is 3. Similarly, degree of 60. Someone, can you say what is the degree of 60 or 50? So there are no subtrees are attached to this node. You can say the degree of the node 60 is 0 because there are no subtrees for this node. Okay, similarly, if you take this one, the degree of the 70 is 1 node with, because one node is attached. Okay, the degree of node is for 90 is 0 because no other nodes or other trees are attached. Okay, these are the different examples. Degree of the tree, this is the node with maximum degree. Okay, because here what is the degree of 20 means there are 1 2 3 nodes are connected, maximum degree is 3. Okay, so if you take any node in this tree, the maximum degree is having only node 20. Okay, so that is the degree example. When you say sibling, the terminology, the node 40, 50 and 60 are called siblings or brothers. Like these are the child nodes for this parent. Okay, so that's why 40, 50, 60 are called siblings. You just remember this terminology. Okay, now come to terminology. Whatever the terminology we have seen, we are trying to map that terminology with the initial employee table structure. Okay, like you have seen the employee table is converted into tree structure like this. Like John is there, John is going to call the root node. After that, John is the called what is this president. He is the president, he is the root node. This is subtree. If you are having like this is subtree. Then these are the some leaf nodes. Like these are like edges, or you may call this as arcs also. Okay, some arcs, whatever the connections you are seeing, this is aux, like this is the parent node, and this node is called this parent, this is the child. When you say Kim is the parent, these are the child nodes. Okay, so now try to observe this terminology. Okay, terminology involved in any tree. And now you take this example. Come to the general example. A is the root node. Okay, like this is root node. B, E, F are the internal nodes. C, D, G, H are the leaf nodes or leaves. Okay, so that is the terminology involved in the trees. Subtrees, whenever you say subtree, this is my root node. If you are having a structure like this is one subtree, this entire thing is one subtree. Within this subtree you may have another subtree also. Okay, so tree is nothing but, if you are having at least one node also, you are going to call it as tree only. That's why even only one data element C is there, that's why we are calling this as subtree. Similarly for other nodes also. Okay, so subtree, this is another subtree. Okay, so like this. So now come to here, when it comes to binary tree. Okay, the name itself binary, bi means two, you have only two nodes, one is left node or another one is right node, or sometimes, okay, a root node or a node is having only two childs, left child and right child, or sometimes left subtree or right subtree. If you are having a structure like this, you may call this as binary tree. Bi means only two. So here we have only two. Suppose if you are having one more node is connected to A, that is not binary, that is trinary, because three nodes you are having. So here only two edges or two arcs are there, we are calling it as binary. Am I right? So a binary tree in which no node can have more than two subtrees. Even you take that internal structure, B is having only two connections. So this may be 2 or either 0 also. Okay, like more than 2 it's not possible. If you are having more than 2, you cannot call this as binary tree. So the basic binary tree definition is, a binary tree is a tree in which no node can have more than two subtrees. In other words, a node can have 0 or 1 or two subtrees. Okay, so if you take this one, this is having only one node, but still you are going to call this form, this is in binary form only, because it may be 0 means this may be leaf node, or it may be one node, or it may be two nodes like this. Okay, so this entire structure is called left subtree and this is right subtree. Okay, so this is called binary tree. Yeah. So right, then tree abstract data type. Okay, tree stores elements. So how you are going to handle or how you are going to store these elements? Okay, generally you have some elements, you already seen. Okay, so tree nodes may store arbitrary objects. Okay, I will give one example. How these trees are going to, okay, these are different tree abstract data type supports. Okay, accessor methods, generic methods, query methods and update methods. Um, okay, we will see one example for tree. Okay, we will see what are these different types of abstract methods it will contain: accessor methods, generic methods and query methods. Uh, ADT supports 4 types of methods. Okay, so what is meant by accessor methods means we use position to obstruct nodes. Okay, like if you want to accessor method means, so in this tree you need to call directly by using the T terminology. Suppose if you call root okay, root parenthesis, it will return the position of the tree's root node. Okay, an error occur if the tree is empty. If the tree is empty, like you are trying to access the data elements directly, you are going to call it as accessor methods. Like parent of P, if you say parent of P, it will return the position of the parent of P. An error occur if there is no parent. Similarly for child also, if you are using the terminology T terminology directly, you are going to call it as accessor methods. So if a tree is ordered, then iterable collection, the children stores, okay, uh, the children of P in their linear order. Okay, anyhow, like come to next one. Generic method means, for example, you want to know what is that size of T, whether the tree is empty or not. Next one, if you want to return that position of trees. Okay, so you can call these functions. Size means it will return the number of nodes in the tree. Is empty means you just test whether the tree is having any nodes or not. Then iterator means return an iterator of all the elements stored at nodes of the tree. It will return it. Similarly, it will return position means return an iterable collection of all the nodes of the tree. Similarly, query methods means like you are trying to check whether is there any internal node is there or not. For that you have a specific function, like it will return boolean things. Okay, whether it is true or false. Is internal P, is external P, is root P. Okay, like P is the data node. Okay, so these are the query methods. Then update method, for example, if you want to modify or if you want to replace any data elements in the tree, you can use replace kind of thing. For example, replace P comma E means what it will do means it will replace with E and return the element stored at node P. Okay, so you will try to update your existing tree nodes. Similarly, we have traversals algorithms. What is meant by traversals means like you are trying to travel in some road, right? Similarly, in tree also you need to travel tree, like previously we have seen some paths or edges, right? If you are trying to visit or if you want to try to visit each and every node in the tree, you are going to call that as travel. Okay, traversal, like you want to visit or you want to travel, you want to cover all the nodes in the tree. Okay, there are different types of techniques are there for traversals algorithm, like one is level order traversals, another one we will see. Okay, what is this level order traversal means? So this is the tree A, B, C, D. Okay, level means this is one level, level 0. First you need to travel this level, then there is no elements here, you come to again here. Okay, it will come like this. This is level 1. Okay, it will starts from the, this is starting, then it will, you can travel like this. Okay, then if there are no data elements, you can come to level 0, level 1, level 2, level 3. Okay, level by level you need to travel. Okay, like you need to visit these nodes. So this is called level order traversals. So this is algorithm how you are going to uh, traverse level by level means to traverse a non-empty order tree. Okay, non-empty order tree means, so tree is non-empty one. So initially you need to take one cube. First you need to traverse this one A, that node will be inserted into NQ will be the root node. Okay, you need to repeat this, okay, until the queue is empty. Okay, so what are the nodes you are, basically I am trying to say is, whenever you are visiting a node, you try to insert that node or you try to use NQ to place that node. Okay, if can use NQ DQ operations, okay, to perform this level order traversals, okay. Then we have another traversals techniques also there, like pre-order traversals. Like pre-order means first you need to visit left subtrees root nodes, okay. Pre, the name itself pre, okay. For example, this is A, B, C. First you need to visit this node, then come to left, okay. Left subtree this one, left subtree this one, left subtree this one. Then you can travel like this. You need to visit the nodes like this. So this is called, this traveling is called this one, then left, left, left. This is called pre-order traversals, the shown, okay. Whenever you travel this thing, A, B, you just observe this thing, A, B, E, H, then I, F, C, then D, then G, H, K, L, M, okay. So this is the pre-order traversals nodes. If you are having a tree like this, so these are the sequence of nodes you need to visit, okay. Note that pre-order traversal tree can be obtained by beginning with the root node. Always you need to start with the root node first, okay. Then you need to stop again, it will come to up to end of the root node. It will start here, again the traversals will come here, then only you need to stop, okay. So the algorithm is visit the root node first, then do recursive pre-order, like as I mentioned, okay. So that is the step-by-step process. Okay, this is the binary tree you already seen, okay. So some terminology also you have seen, okay. Now I will write Python code for this. Then I will explain this one, and then I will give Python code for binary tree, okay. So what is the difference between trees and binary trees? Can you just tell me what is the difference between tree and binary tree? So generally tree may have any number of nodes, but binary tree means you may have 0, 1 or at max 2 nodes only, okay. So that is the difference between trees and binary trees, okay. Then come to here, so there are another trees also there, like full and complete binary tree. So these are 5 binary trees with 3 nodes, okay. So if you are having a tree, these are the, if you are having 3 nodes, then this is the possibility you may get this many number of binary trees, okay. If you are having 3 nodes, you can represent binary tree like this, n1, n2, n3, and this is the another one, and this is the another shape of binary tree, then this is the another shape, then this is the another shape, okay. So total how many are there, okay. So 5, okay. Now I will give Python code for binary tree. So based on these basics, okay, I am trying to write Python code for this binary tree, uh, and then we will see this traversals, traverse algorithms in binary tree. Okay, so always whenever you want to, okay, basically I am trying to create node by using class. Okay, so everything we are going to take in terms of class and objects. Class node, okay, I am declaring my tree data element as node, class node. Then you need to define the initialization. Okay, so we have some predefined functions are there in Python. So like init self means that particular node. In the previous case, whatever the nodes, root nodes, whatever you are seeing, so that will be the self node. See here, whenever I typed self node key means the value. It's giving the code for insertion, everything. But as of now, self node I am trying to give just self means the same node. Just so init is the function, a special function, special built-in function which is available in Python. Def is used for to create. I think you already know, you are trying to define a function. Okay, init function self node. Then you are trying to self dot key means you are trying to call that root node value. Okay, or self node value. You are assigning some key, some value. Okay, then after that I am declaring self dot key is over. Key means root node. Self dot left is so none. That means I am not giving any value now. Okay, so my left subtree is none. Similarly, I am creating right node. So key is the key node like root node. So this is the declaration. We are trying to define a node here, class node. Inside we are trying to give initialization function self comma key. Key is the value. So initially I am trying to self dot key equal to key means you will get that value. After that you are giving left and right nodes will be the empty nodes, or you are not assigning any data values now. Okay, now this is the function how to declare a node. Now what we will do is we will define whatever you have seen. Okay, we will see the traversals. Okay, so what are the different traversal techniques we have seen? In order, so I will write Python code for traversals. Okay, so what we will do is I am trying to define one more function, in order root. Okay, so initially I told pre-order means the root node will visit first, post order means root node will visit last. Now initially I am giving in order root. If the root, now you declare if root this value, you need to visit this root key. Okay, this key value and this key is both are same. Okay, in order means you need to print. So first you need to print the left node, then root node, then right node. Okay, this is the syntax for in order. Similarly, pre-order also you need to define pre-order root node. Pre means you need to use it first. Okay, so if it is root, then what you will do, you try to print that root node, then pre-order of root comma left, then root comma left. Okay, pre-order means root will come first, then left will come, then right will come. Okay, similarly post order, So if root, okay, post order means the root node will come at the end, okay, only difference. In order means the root node you are going to visit in the middle. Pre-order means first, post means at the end, okay. So these are the three traversals syntaxes, okay, how to define this thing, okay. Now what we are doing is we are trying to construct a tree, right? For constructing the tree, what you will do is how to construct this thing, okay. You need to have data elements, right? You need to maintain data elements. These are the three different. Now, so this is the root. So I am giving the nodes is like this, okay. Root equal to node of 1 is the first root node, then left node will be 2, right will be 3, then root left is 4, that means 2 is connected to 4, root right is 5, okay. And then what I am doing is I am trying to print this in order sequence, okay, like this is giving that, okay, print in order of. Now you are trying to call this one, okay, you just write this print in order, print pre-order, and then print post order, okay. So this is how to create a binary tree, and then you are trying to traverse a binary tree, okay. So these are three traversals techniques. Now what we will do is we will try to execute this one, okay, we will see. So this is how, okay. So this is the order. Based on these root nodes, you are trying to print these three traversals orders, okay. This is in order sequence, then pre-order sequence, then post order sequence, okay. Any questions? How to construct or how to create a binary tree using Python, and then how to traverse each and every node? So if you understand this, the next, if you understand the binary tree, then I will explain some more. Okay, so I will explain some more trees. Just a minute. So the next one is you have one more concept, like I think you already seen, okay, full and complete binary trees, okay. So when you are going to say a tree is called full binary tree, or a tree is called complete binary tree. So whenever you want to say a binary tree is said to be full if all its leaves are the same level, okay, all its leaves means leaf nodes are at the same level, and every interior node has two children. Interior node means internal nodes. Whenever you want to say full, all the leaf nodes will be in the same level, and every internal node has two children. Come to here, a tree is called complete binary tree. It may be either full binary tree or one that is full except for a segment missing leaf nodes. Okay, it may miss the leaf nodes also. Okay, so the best example is full. These are two different kinds of, okay, full and complete binary trees. Can you say which one is full and which one is complete binary tree? Based on this definition, a binary tree is said to be full binary tree if all its nodes are at the same level and the internal nodes has two children. If you want to say complete binary tree, either a full binary tree or there will be some exemptions. Okay, now tell me which one is full based on the two definitions. Anybody is there? So you may call, okay, this tree is called full binary tree, this is called complete. Okay, this is complete, but these nodes, okay, you don't have any children. Okay, based on this definition. Okay, this is full and then this is complete. Okay, come to here. Okay, like full you have seen, right? Like this is the example for full binary tree. All the leaf nodes having at same level, and then these are the internal nodes will have two children. These are one type of internal nodes, I mean level 2 internal nodes. Here also level 1 internal nodes. This is also having two children, so that's why we are calling it as full binary tree. This is the example, and this example is called complete binary tree, because here you don't have some leaf nodes, so at the same time this node is missing um, one child. Okay, if you are having, this is complete binary tree. Okay, like complete binary tree is a subset of full binary tree. Okay, full binary tree is the maximum one. Okay, so it's superset. Full binary tree is the superset, complete binary tree is the subset. Okay, so whenever you just remember, these are the some fundamentals. Like in full binary tree, if the height h, okay, the full binary tree of height h has 2 power h leaves. Now come to here, what they are trying to say is, okay, this is height h. Okay, 1 2 3 4, the height means the levels. Okay, if you are having height h, there are 4 levels. How many children are, how many nodes? Okay, this is level 0, level 1, level 2, level 3. Similarly, level or height. Okay, so the height of this tree is called 3. Okay, 1 2 3. Whenever you want to know how many leaf nodes are there, if the height is 3, then you can say 2 power h leaf nodes. That means 2 power 3, there will be 8 leaf nodes are there.
Right now.
Okay, then how many internal nodes you have? Internal means, in this case, this is 1 2 3 4 5 6. So what is the formula to compute internal nodes for full binary tree? M equal to h. So all these are internal nodes. How many internal nodes means 2 power h minus 1. So how many nodes are there now?
So can you repeat what are internal nodes?
What are the internal nodes? I don't know, maybe you joined now. Okay, internal nodes means like these are the leaf nodes. All these are okay. Like this is internal node, this is internal node, this is also internal node. Okay. So apart from leaf nodes, whatever the nodes that is
So,
present,
sir, hello.
yeah,
Sir, when I going to talk about total number of internal nodes, so how many number of internal nodes in this diagram?
yeah, this is one internal node,
Like,
another internal node.
so I can visualize it.
Yeah, can you visualize these things? 10, 20, 30, 40, 50, 60, 70. You are going to call it as internal nodes only. These are
You
the
mean total number of nodes?
no, no.
That's our
Total
internal
number
nodes.
of nodes is how many nodes are there in this tree?
Uh, there are two diagrams now. In first diagram, 8 plus 4 plus 2 plus 1. Is that total
Can you
number of
see
internal
this
nodes?
diagram, the current diagram, full binary tree?
Yes,
10,
sir.
20,
There are
30.
two diagrams now.
Not two diagrams.
Hello.
This is only one tree, right? Full binary tree. Hello?
Sir, I'm getting little confused because I am joined late.
That's okay, no problem. You know that basic fundamentals of tree, right? Only one tree is there,
Yes,
right?
sir.
Can you see this tree?
Yes, sir.
I don't know.
Yes, sir. Yes, sir. Yes, sir.
Now you know terminology of tree, right?
Yes, sir.
These are the leaf nodes. Whenever you want to say
Yes,
internal
sir.
nodes, apart from the leaf nodes, whatever the nodes that is present in the tree, you are going to say it as internal
Internal
nodes,
nodes.
okay, including root node also.
So,
Hmm.
in this diagram, 40, 50, 60, 70, 20, 30, and 10 are internal nodes.
Yes. So whenever a
Uh,
height,
so
huh,
so in full binary tree, excluding the leaf nodes, other nodes are internal nodes.
yes,
So here we going to count internal nodes. There the total number of internal nodes are six. Sorry, seven.
it's 7. Like this tree is having height of this tree is h, okay. In this case, height of this tree is having 3. If you want to
Yes,
know
sir.
the formula for internal nodes, uh, that will be 2 power h minus 1. This is binary tree, that's why 2 is
Sir.
there. 2 power h minus 1. The height is 3, 2 power 3 is 8, 8 minus 1 is 7, 7 internal nodes. So if you want to know the leaf nodes,
Total number of each minus one.
yeah,
Okay.
so that's what
Yes, sir.
this formula, a full binary tree having height of h, okay. So in this case, in this example 3, maybe in sometimes you may get 4, 5 like this also. The height of the tree may be varies, okay. So
Yes.
then the
Thank you
leaf
so much,
nodes
sir.
will be 2 power h and then internal nodes will be 2 power h minus 1, okay. So this is just
Sir,
for,
you mean height?
yeah, h means height.
Yeah, sir. You mean the total number of steps done by binary tree, just like 10 to 20, 1 each, 20 to 40, 2 each, and 40 to 80, third each. Is like that.
Yes, I already explained. I hope you joined now itself. The first hour, okay, I explained this.
Sir,
Height of the tree
due to
terminology,
some
okay.
reasons, I joined late, sir.
Yeah, yeah.
So
Height
I'm
of the
recalling
tree
that.
is nothing but the path length, okay.
Yes, sir. So I'll
So this is height.
मतलब इस अलग तरीके से भी याद रख सकता हूँ ना जैसे कि 2 to the power 0 plus
I will
1 plus
show
2
you one
इनकी
slide.
टोटल करूंगा तो
I will just show you this thing, okay. Some tree
yes, sir.
terminology I explained. So whenever you want to say height of a node, it's the length of the longest path from n to the leaf node. N means that root node. So what is the longest path in this tree?
So the formula which you given is only for the full binary
Full
tree.
binary tree, yeah.
Thank you, sir.
Hmm.
I got the point.
Okay. So similarly, if you want to know how many nodes are there, this will be the shortcut formula. to compute the nodes that is present in full binary with height h. Okay, what is the height means the longest path. This is not the longest path from root node to leaf node. Okay, suppose if you have one more node here, then in this case, okay, then this is not
So
full binary.
height will
I'm
be
just
4.
saying, yeah, it is 4, but if you are having one more node here, it is not full binary tree, it is complete binary tree.
Yes, sir.
Okay, you just remember. Similarly, for complete binary tree also, if you are having height like this, um, so we can able to compute the number of nodes, the formulas like it will be like this. Okay, log of n. Okay,
I don't know the point is gone or not, but I want to recall the heap also.
as of now we are not explaining heaps and all. Just binary tree,
Oh,
and then we are explaining full binary and complete binary trees concepts only. Okay,
okay.
now
Thank you, sir.
come to here, how to implement these.
सर
Yeah,
अभी मतलब आप पढ़ाने वाले हैं क्या?
can you speak in English? Just
Okay. Sir, I'm little confused now. Just wait a minute. So, sir, are you going to teach the keep now?
no, not now, maybe later. As of now, the week 7 lectures are related to trees only, right? I'm just giving some more.
Yes, sir.
NPTEL week 7 is related to trees. I am explaining different trees concept, and then the Python code for those trees. I'm not explaining heaps in this session. Maybe next live session I may explain.
Okay, sir. Thank you.
So if you are having a tree like this, you want to use your array to implement this tree. Okay, you need to follow. Uh, the structure will be like this, array structure. Okay, the root node will be stored like this, then level by level you need to go. Okay, this is another level B, and then C. After C only you need to come to the next level. Okay, like this is the storage, how you are going to store all these three nodes in the array. Okay, the equivalent array representation for this tree. Okay, so this way. Similarly here also, see here we have a tree like this, A, B, C, D, E, F. See here we are trying to implement this tree by using array. What will happen is in real time, A, B, C, okay, then D, E, F is there. See here there is no element. Okay, but you are trying to keep that empty slot for this element. Okay, then G, H, I is there. Okay, and then J you are trying to keep again for E also. After I you are leaving one more space. Okay, so this figure shows the incomplete. This tree is called incomplete binary tree because binary tree means every node will have two children. I mean, at most two children or zero children. But when you are having this kind of thing, okay, you can say this is incomplete binary tree, and the natural mapping of nodes into the array. Okay, this is called some gaps. Okay, you are trying to waste like in terms of memory aspects, you can say you are trying to waste some memory here. Okay, so that is the disadvantage. Okay, so what is the disadvantage if you are implementing tree using array means you are trying to waste some space like this. Okay, like some memory wastage will happen. So to avoid that, what we are doing is we are coming up with one more data structure to implement the tree data structure, that is linked list implementation. So like this is normal structure. Okay, like structure for you have data and then left and right node. Binary means left and right childs only. You are trying to point out by using some pointers. You are trying to point out the left node and right node. your actual data will be integer data. Okay, like you can define with the help of this is like C code snippet. Anyhow, we will show same thing in Python also. The concept is same only. You can represent like this to avoid that space. Okay, now come to here. This is the linked list implementation. Suppose if you have a tree like this, so this is your 10, that will be the root node or data node. Then left child, you can point out the left node to another element again. So here each and every time left light. Okay, so what you are doing is you are trying to give that left to the another pointer. Okay, for example, if you take 20, so there will be one more node is there, that is 40. So 40 will be there. Again you need to check for this node, is there any further left and right nodes are there, or left and right subtrees are there. If nothing will be there, what you are doing, you are trying to place null here. Okay, so that means there will be no further more nodes are there. Okay, similarly for 50 also, similarly for 30 also. Okay, so this is how a tree data structure will be implemented by using linked list. Okay, so if you do like this, okay, what will happen is, so this you can do in dynamic fashion. So like array will be static thing, at the same time you are not going to waste your memory while implementing this tree by using linked list. Okay, so anyhow, whatever we mentioned, different data structure, they have their own advantages and disadvantages. So whenever you are implementing tree with array, so you have some advantages. What are the advantages means some direct access will be there. At the same time, finding the parent and children is very fast. Right, what is the parent of if you are taking array implementation, the parent is the first, whatever the element you are going to store in index 0, that is the first one, that is the parent node. Similarly, the end, whatever the nodes you are storing at the end of the array, so those are the child nodes. Okay, only disadvantage, you are trying to waste the memory. At the same time, whenever you want to insert or delete, if you want to take insert operation and delete operation in the array, again it's very difficult. Okay, it will be costlier. The costlier means in terms of space and time only. Okay, so and then this array size and depth, this array size is you are going to fix initial time itself. Okay, so these are the three disadvantages, like wastage of memory, insertion and deletion will be costlier, then array size and depth. So when you take the advantage, whenever you are implementing the tree by using linked list, the advantage will be you are not going to, whatever the disadvantages are there for array, so that will be the advantage for linked list. There will be no wastage of memory. Insertion and deletion will be very easy. Okay, if you want to delete anything. Okay, so similarly, whatever the advantage will be there in array, that will be the disadvantage here, because we does not, I mean, this kind of implementation, it does not provide any direct access or any additional space in each node. Okay, so those are the advantages and disadvantages. Okay, so I hope I explained in order and pre-order, post-order also. Can you take this example? Can you tell me the in order sequence for this? I am just giving one exercise for you. This is a binary tree. Can you tell me the in order, you apply in order traversals technique and find out the so what is this in order thing? So you need to visit which node first? In order traversals. So you need to travel like this. In order to travel says always left to subtree. Okay, left to subtree. The first node you need to visit this node first. So H will come. Then you need to visit. Traversal means like traveling only. You need to visit this one D. Then you can come like this. Then I. Always left to subtree left node. Okay, you can start like this. You can go I, then B, then you need to come like this. J you need to visit. E, K, then A, so then L, then F, then M, C, N, G, O. This is the in order sequence. Pre-order means always you need to start with root node. You can come like this, pre-order. Okay, A, B, D, H, I, then E, J, K. So pre-order means what you are doing is you trying to pre means the name itself. You need to visit the root node first. Okay. In means in between left and right node. Okay, you need to visit. Okay, for example, if you take this node, there will be no left and right nodes. So that's why you are visiting this node first. So if you are having one more node here, then you need to, okay, in between your left and right subtrees or nodes, you want to visit this node. Okay, so then A, like pre-order I am telling. L, I mean after A pre-order you will get C, F, L, M, and then G, N, and then O. Like post order means you need to visit your root node at the end. First you need to visit the left and right nodes, then you need to visit the root node at the last. Now come to here H, it will go like this. The last left subtree you don't have any nodes, then it will go like this. Okay, left and right node, there will be no left and right node. Then this is the root node, then again it will come. After H it will go I, D, then it will come like this. Okay, J, K, E, B, then it will go like this. Then you can visit E, M, F, then it will come N, O, G, C, A. Okay, so these are the in order, pre-order and post-order traversals. Okay, like if you want me to write how to write Python code for tree implementation, okay, by using linked list, I will give one example. How to represent these nodes. Okay, I will show you. So like previously I explained, right, this in order and all. Similarly, I will explain. I will show you one example. See, you can see here, like this is simple tree, which is having some nodes A, B, C, D, E, F, and then left and right. Okay, so how to implement this tree with linked list means, like previously I showed, right? And this is the basic structure, class, binary, whatever the previous thing we have seen. Okay, so that is the implementation. Key root node. Okay, like self dot key, you need to pause that root node, then left child. Okay, initially this will be none and none. Now come to here, so you need to insert left node. Okay, self dot left node. If you want to insert some new node, I mean whatever the node you want to insert for left subtree, that you are going to call it as new node. Okay, so for that what you are doing is you are trying to call this function recursively. What is this function? Binary tree function with the help of new node. What this is your binary tree class. You are trying to give that new node, it will come to here. Okay, each and every time this procedure you are trying to call recursively to insert the new nodes. Okay, so that's the implementation. How you can see here, see that entire binary tree. So this is initialization function. Then insert left. If you want to insert left, you need to follow this syntax. Okay, so if there is no left node, that left node is I mean no left node, you need to call that function. So else case what you will do is you just insert it, then assign. You can take some temporary variable, you assign to left node. Okay, then insert right node. This is the syntax for right node. Okay, so you need to write the basic syntax, so like this. Okay, just try to practice these things. Okay, how to implement tree by using arrays and linked list, you will get some idea. Then you implement the tree traversals things. You can practice these examples with Python only. Okay, so that's it from my side. Okay, any questions? If you have any questions, you ask me. Otherwise we will connect in next week. Okay, thank you all. Good night.